Good day, everyone, and welcome to another episode of Simple Science with Sir S. For today, we will be dealing with the difference between speed and velocity. But before we proceed with our topic for today, let us first have a recap of what we have discussed last time, which is the difference between distance and displacement. I have here statements which we will classify as either distance or displacement or both. Let's start with the first one. Measures the total path traveled by a moving body. So for this statement, this belongs to distance. Second one, units are meters, kilometers, and miles. This belongs to K. Both distance and displacement have the units of meters, kilometer, and mile. But the only difference is one has direction and the other one only has a magnitude. Next one, vector quantity. So this is for displacement, correct. Vector quantities are quantities with both magnitude and direction. So therefore, displacement has both magnitude and direction. Next one, measures the initial to final point. So this is displacement. Displacement refers to the measurement from the initial to final point, irregardless on how far an object travels, as long as it only measures how far the initial from the final point is. We have scalar quantity. So this is for distance. Next, the first picture, what type of quantity is being shown here? Is it distance or displacement? So the first picture shows displacement because the straight line only points from the initial to final point. And the last picture is an example of distance. Because when we say distance, this refers to the total path traveled by a moving body. Okay, now let us proceed with our lesson for today. For today, we will be dealing with objects that are in motion. Objects are considered in motion if it changes its position relative to a reference point, meaning if an object changes its position relative to a reference point or it changes its place relative to a reference point, then an object is in motion. But what do you mean when we say reference point? Reference point is an steady object or an object that doesn't move that serves as your point or your guide whether an object is moving or not. The Earth's surface is used as a common reference point. So for you to know what a reference point is, so let's say for example, um, your reference point is the road and you're riding a bus. So if the bus moves from point A to point B, therefore the bus is in motion. And you are in motion also because you changes your position. But if your reference point is the bus, even though the bus traveled for how far, you are not in motion because you are riding the bus and you are not changing your position. Sometimes reference points are also moving objects such as cars, boats, airplane, or any moving object. In describing motion, we use several quantities, but for this time, we will only be dealing with speed and velocity. Let us first discuss what speed is. Speed is the rate at which an object is moving. Speed is also defined as a distance per unit of time. Again, when we say speed, this refers to how fast an object is moving. So it needs a change in position. If there is no change in position, therefore there is no speed. Speed is equals to distance over time, or mathematically, that is S, is equals to d over t, wherein S is the speed, and d is the distance, and t is the time. Like distance that we have discussed a while ago, speed doesn't depend on direction because both speed and distance are scalar quantities. For us to have an example of what speed is or how to calculate speed, I have here an example. Here's a car that drives 100 meters in 5 seconds. The question is, what is the average speed of the car? When we talk of average speed, we deal with all the distances covered by a moving body divided by the total time taken. But for this example, since we only have one distance and one time, so we will only use the givens here. So here's the illustration on the problem. So a car moves at 100 meters in 5 seconds. So from this question, the unknown is the speed. For us to calculate the speed, we need to encircle or get all the givens that we can have from the problem. So from the problem, we have 100 meters and 5 seconds. So from these givens, 100 meter is considered as our distance and 5 seconds as our time. The formula in finding speed is equal to distance over time. Substituting the values, speed is equals to the value of d, which is 100 meters, over the value of t, which is 5 seconds. So 100 divided by 5, so we will come up with 20 meter per seconds. So the car traveled 20 meters every 1 second. But what is the difference between speed and velocity? When we say velocity, it is symbolized by small letter v. This is also defined as speed with direction. Velocity is equal to displacement over time. Take note of the difference. When we say speed, we calculate speed by dividing the distance divided by the time. But for velocity, we use displacement divided by time. Mathematically, v is equals to displacement divided by time, or delta d, or change in distance divided by time. Take note that velocity both has magnitude and direction. When we say magnitude, this is the measurement of the distance, or when we say magnitude, it is a measure that has a value. Example, 7 kilometers, 32 kilograms, 7 Newton. Those are examples of magnitude. The difference between velocity and speed is velocity both has magnitude and direction. To give us an example or comparison between speed and velocity, I have here an ant. Let us observe or calculate the distance and displacement, the speed and velocity of the ant. Let's start with this one. So the ant moved from this point after that and then goes back to this point at 5 seconds. The question, what is the distance covered by the ant? So from our illustration, we can see that the ant moves from this point, from point 0 up to point 3. So we have from 0, you have 1, 2, 3, 4, 5, 6, and then 7. So therefore, the distance covered by the ant is 7 centimeter. It is because when we say distance, this refers to the total path traveled by a moving body. So the ant moved from point O up to point 3. When we say displacement, it is the measurement from the initial to final point. Since our initial point from here is from point 0 and our final point is at 3, so we will measure from point 0 to point 3. So this is 1, 2, 3. So the displacement now is 3 centimeter and the ant is located east of point O. So therefore, our displacement now is 3 centimeter east. It is because the ant is located 3 centimeter east from our initial point, which is the 0. Now, what is the speed of the ant? Since for us to calculate speed, we will divide the distance traveled divided by the time. Take note that for distance and displacement of this ant, we will use the same time, which is the 5 seconds. So distance traveled, which is 7 centimeter divided by 5 seconds, so the speed of the ant now would become 1.4 centimeter per second. How about the displacement of the ant? So the displacement of the ant is 3 centimeter. Take note that it is different from the distance that we have calculated. If we are trying to find the velocity of the ant, we will use the displacement and the time taken for the ant to reach the point 3 or the 3 centimeter mark. So we will now use the displacement, which is 3 centimeter east divided by 5 seconds. So we will now have 3 centimeter east divided by 5 seconds. So we will now have 0.6 centimeter per seconds east. Take note that there is a direction for you to consider it as a velocity. Even though they have the same time, but they have different distance and displacement, so they have different speed and velocity. Okay? Here's another example. This example deals with speed and velocity with the same value because no direction is being indicated on the distance. So let's have the first one. So we have here a table, runner A, B, C, and D. Runner A runs a distance of 200 meters in 40 seconds. Runner B is 300 meters in 60 seconds. And runner C is 100 meters in 10 seconds. Runner D is 250 meters in 20 seconds. So, the first question is which runner runs the greatest distance? So, by merely looking at the distance column, you will notice that runner B had a distance of 300 meters. So, runner B has the greatest distance. Next question, which runner is the fastest? So for us to know which runner is the fastest, we need to calculate the speed or the velocity of runner A, B, C, and D. So for runner A, 200 meters divided by 40 seconds, so we will have 5 meter per seconds. So for runner A, the speed or the velocity of runner A is 5 meter per seconds. For runner B, 300 meters divided by 60 seconds. So we will have still 5 meter per seconds. For runner C, we have 100 meters and 10 seconds. So 100 meters divided by 10 seconds. So we have 10 meter per seconds. And for runner D, 250 meters divided by 20 seconds. So we will have the answer as 12.5 meter per seconds. So among the four runners, we can see that runner D having 12.5 meter per seconds is the fastest. Next question, question number 3. Which is the slowest? So from the data that we have obtained, both runners A and B had a speed of 5 meter per second. Runner C has 10 meter per second and runner D has 12.5 meter per second. So from that, we can say that runner A and B are the slowest among the four. Last question, which runners has the same speed? So since both runners A and B has a speed of 5 meter per second, so therefore, for this question, the answer is runner A and B. Next one. Here's another problem solving example. A person walks 5.0 kilometers in 2 hours, then walk 2 kilometers west in 1.0 hours, and finally he walks 10.0 kilometers east in 2.0 hours. The question, what is the person's average speed for the journey? And what is the person's average velocity for the journey? So for this problem, we are looking for the speed and the velocity of the person. Take note that all the movement or all the quantities the person take has directions. The first one is 5.0 kilometer east, and then 2 kilometer west, and then 10 kilometer east. So let us first answer question number 1. So to find the answer for question number 1, we need to add first all the distances that the person took. So let's start with the first one. We have 5 kilometers, 2 kilometers, and then 10 kilometers. Since on speed, we are using distance and distance doesn't require direction, what we only need to do is to add all the quantities here, all the distances. So we have 5 plus 2 plus 10. So we will have the distance of 17 kilometers. And then before we calculate speed, we need to find also the total time taken for the person to complete the path. And that is by adding 2, 1, and 2. So we will have the total time as 5.0 hours. So with this, we can calculate the speed of the person. So for us to calculate the speed using distance as 17 kilometers, time as 5 hours, and the velocity of the unknown. Sorry, this is speed as the unknown. So speed is equals to distance over time. Just want to correct this one. This is letter S, not letter V. So S is equals to D over T. And then S is equals to the value of the distance, which is 17 kilometers, divided by the time, which is 5 hours. So 17 divided by 5. So the speed of the man is 3.4 kilometer per hour. So that means that the man can travel 3.4 kilometers every hour. The man covered 3.4 kilometers every hour. Now, going back to the question, a person walks 5 kilometers east in 2 hours, then he walks 2 kilometers west in 1 hour, and finally he walks 10 kilometers east in 2 hours. Let us answer the second question. What is the person's average velocity for the journey? So, for us to answer the velocity, we should get first the displacement of the person. So, let us try to put it into a diagram. So, we have 5 kilometers, 2 kilometers west, and then 10 kilometers east. So, let us put it into a diagram. So, let's say, for example, that this is the man. The man starts from point 0 and then walks 5 kilometers east. So, from that point, the man walked up to this point and then walk 2 kilometers west. So the man goes back by 2 kilometers. So now he will land at point 3 and then walks 10 kilometers east. So from this point, the man walks 10 kilometers. So you will see now that the man is located at 13 kilometers and the position or the direction is towards the east. So the displacement now is 13 kilometers east. Again, in calculating velocity, we need to find also the time. So the time now, we need to add 2 hours, 1 hour, and another 2 hours. So we will now have the time as 5.0 hours. You will notice that the time doesn't change because time is also an example of a scalar quantity. So it doesn't need direction and that it doesn't the time is not affected by the change in direction. Now let us calculate the velocity of the man. So having a distance of 13 kilometers towards the east and a time of 5.0 hours, so we have now the velocity as the unknown. So using the formula, velocity is equals to displacement over time. Velocity is equals to 13 kilometers east divided by 5 hours. So 13 divided by 5, we will have the answer as 2.6 kilometer per hour is. Take note that there is always a direction when we talk of velocity. Okay, so again, the difference between speed and velocity, first one has a direction and the other one does not. Okay, now I have here questions to see whether you understand the difference between speed and velocity. Using your papers, identify the following statements as either speed or velocity. You will just simply write speed or velocity. Number 1, distance traveled per unit of time. Is it speed or velocity? Next, depends on direction. Number 3, 35 meter per seconds is. Number 4, 45 kilometer per hour. Number 5, displacement per unit of time. Number 6, does not depend on direction. Number 7, speed with direction. Number 8, total distance traveled per unit of time. Number 9, S is equals to D over T. And number 10, V is equals to D over T. So while you're answering this one, just put it aside and then answer the next part, which is a multiple choice question. So the direction is to choose the letter of the correct answer. You will only write the letter of your choice on your answer sheet. Question number 1. The distance traveled of a moving body per unit time. A, velocity. B, speed. C, acceleration. D, force. Question number 2. Which of the following exhibits velocity? 1, a car at rest. 2, a moving object that changes its direction. 3, a running man traveling at 20 meters per second north. And 4. A toy car runs a 2-meter distance. The options are letter A, statement 1 and 2. Letter B, statements 2 and 3. Letter C, statements 3 and 4. And letter D, statements 1 and 4. Question number 3. An object moves at a constant speed of 6 meters per second. This means that the object A increases its speed by 6 meters per second every second. B doesn't move. Letter C has a positive acceleration. And letter D moves 6 meters every second. Question number 4. While riding a vehicle at a uniform speed of 36 km per hour, calculate the distance of the vehicle after 3 hours. A. 12 kilometers. B. 18 kilometers. C. 33 kilometers. And letter D. 108 kilometers. Question number 5. A toy car moves 8 meters in 4 seconds. At a constant velocity, what is the car's velocity? A. 2 meters per second. B. 0.5 meter per second. Letter C. 32 meter per second. And letter D. 12 meter per second. Now, let us check your answer from the two activities. Let's start with the first one. Identify the following statements as either speed or velocity. First one, distance traveled per unit of time is speed. Depends on direction, velocity. 35 meter per second is velocity. 45 km per hour, speed. Displacement per unit of time, velocity. Doesn't depend on direction, speed. Speed with direction, velocity. Distance, the total distance traveled per unit of time, speed. S is equals to D over T is a formula for speed. And last one, V is equals to D over T is for velocity. For our multiple choice questions, number 1 is boy, number 2 is boy, 3 is dog, 4 is dog, and number 5 is letter A. After checking your answers, kindly send your score to your teacher and that will serve as your attendance for today. That's all for today and good day everyone.